mixture of students in the class. Not everybody is from high school, not everybody is at the college level. There are other students too, so we have to respect the classroom. Again, if your friends stay away from each other during class, you are not helping by sitting next to each other, you are disturbing the other person for your kind information. What's the difference between a molecule and compound? Who wants to volunteer? Go ahead.
Molecule is of the same element. Compound is two different elements combined.
Can you be a little more specific? It's not complete.
Molecule is more than one atom.
Exactly.
But the same element.
Exactly. See, you're getting there. You know the stuff. It's how you put it across. Okay, what's the difference between a solution and colloid? Somebody else. I'll come back to you. What? Solution and colloid.
The solution is homogeneous and you can see through it. In a colloid you can see the solute.
Right. You cannot really see the solute, but it's kind of cloudy. Like in a suspension, you can see the solute. Okay, so solution homogeneously, completely mixed, and it's transparent or translucent, whereas in a colloid, it's also completely dissolved, but it's cloudy. Usually, if you have proteins in solution, it will look like that. And if it's oil or any other particles that don't dissolve, then you will see them floating. If it's solid in liquid or liquid in liquid, depending on what you're mixing, it may stand alone like two layers. Okay. What are the 4 types of bonds? From the strongest to the weakest. Let's do, because you started with the strongest. Take your time. I have a few more minutes before I move on further. Ionic. Yeah, covalent comes first, ionic, hydrogen, and the weakest are the van der Waals forces. So which one involves sharing of electrons? Covalent. Which one involves attraction between electric charges? Ionic bond. So what are ions?
Atom, charge atom?
Yeah, electrically charged atom. We can to be more complete. Okay. Which one is the valence shell? Any new voices? Outermost shell. Okay. I want to give everybody a chance. Okay. You can all participate as well. What about the mass number or atomic number? What does that mean to you? The number at the bottom of each box. Mass of the? More correctly, mass of the nucleus. Can you be more specific? Yeah, sum of the protons plus neutrons. That's the. How do you get the molecular mass or weight of some compound? Yeah, basically, yeah, but if you know what those numbers are, you basically see the number of atoms multiplied by that number and then add up. Okay. So what is, that leads to molarity. What is the molarity of the solution? Molarity, mole, liquid. So can you relate that information, tie them all together? You're getting there, but I'm looking for more complete answer. 1 second. Yeah, mole. Moles, number of moles in 1 liter of solution. Okay. So 1 mole of something, if you take glucose, 1 mole will be what we looked at the number 180. That's 180 grams. If you put in 1 liter, that's 1 molar solution. So molarity is the number of moles in a liter of the solution. Yeah. And how do we normally measure, or in common use, they use millimoles. That's 1,000 of a mole solution. Okay. So like this, you have to throw yourself questions besides the questions they have in the book, and you have to ask yourself when you read, not ask the questions the day before the test, and don't come to me with questions the day before the test. I'll be physically available, but I can clarify anything, any doubt you have before, but not the day before the test, which is coming soon, the week of the 20th. We have a couple of days. I was looking at my calendar. Here, let me make sure Okay, the week of the 20th is our 5th week. We meet Tuesday, Thursdays. Okay, so as of now, we will have our exam either the Tuesday or the Thursday, which is the 25th or the, let me check again, the 25th. Yeah, so we will do it either the 20th or the 25th. Hold on. Okay. So we will do it on the 25th. Okay. Don't ask me what chapters. Already you should know.
Oh, I'm not.
No, not you. I'm talking to the class. I don't talk to a single person. Okay. I'm talking to the whole class. It's not personal. So whatever will be covered up to the previous class will be on the test. So we will cover what we had planned. You know what we have planned, it should be in that sheet I emailed you long back. Okay, moving on. Okay, so hopefully you are up to date with your information that we discussed already, and I did email for some of you who need the extra help some video links. Okay, it helps if you try to look at them. So I listed quite a few topics that you may need help with, additional help. But if you don't open that email, nobody can help. Okay. Metabolism. What do you mean by metabolism? We are continuing from page 58. We need to do page 56 as well. So we stopped at pH if I'm correct. So let's continue with energy, page 56, and then move on to 58. So what do you mean by energy? What do you mean by work? Work is to do something. So when you work, you get the reward. Okay, it could be your salary, it could be a degree, it could be whatever. You have to do something to get rewarded, right?
Right.
Or a nice grade. And in order to do that, you need to not only have skills, you need to have the energy. Okay, energy is the capacity or the ability to do something. Okay. Then you have different types of energy. If you see, they are italicized in that paragraph, or if you looked up already, potential and kinetic energy. If you're looking up the first time, you're fishing for that word. If you did your homework, unassigned homework, you know where they are. Potential energy has the potential. So we all eat something or put gas in the car, or you're ready to jump from the diving board. So at that point, everything has potential energy. So potential energy means energy in a stored form. But when you say kinetic energy, that's when it's in an active form. So when you digest your chips or digest your hamburger, or you're running your car on the gas, it's being used and put to action. Okay, so that's your kinetic energy. Or when you're diving, or a rock is rolling down the hill, the water is flowing down the dam, all that's kinetic energy, when something is being used instead of. So we all have the potential to do well in the class too, but you have to put it into action. Then only you're going to do well. Okay, so everything we study relates to exactly everything we do at every moment. Whether it's class or science or chemical reaction, we're all the same thing in one way or another. So then you have free energy. Free energy is again another variation of the definition, amount of energy available at a given point to do work. Okay, you may have used some energy, right? While coming, finding a parking space, getting upset, angry, you already used some energy. Okay, and while coming here, maybe if you were reading, if you did that, then you used up some energy. So whatever leftover energy is your free energy available. available to pay attention to this class lecture, right? Then chemical reactions, there are all kinds of reactions. As we know, the ions, and they bump into each other, they do things, they make compounds, make macromolecules, and so on. They make and break. It's like in real life, you make up and break up. Okay, so this is called reaction. Okay, you have chemical reaction. By definition, is a process in which a covalent or ionic bond is formed or broken. This is what I like about science. It's like whether you really care for a person or it's just attraction. Bonds are also like that. Whether it's a covalent, whether it's ionic. Okay, so depending on the situation, you have different bonds, and some bonds are stronger than the others. But if you see, the reactions can be written in a form like a formula. As you can see, one example there, they call it a chemical equation. What is the essence of a chemical equation? What do you see there on the left hand side? What do you see on the right hand side? What does that arrow mean? What do we call the ones on the left hand side? Somebody must know. Reactants. Reactants. And what do we get? Products. What does the direction tells you? Which way the reaction is going to go? Could be ending up with the products, or you may come back to where you started, right? You can think of real life too. Okay, so which way you go? So these reactants react and form some products, or if it's the other way around, they become the reactions. Which one? The products, and you get the what you started with as reactants. So in that case, most reactions are reversible. So if you see the two arrows, that means it's reversible. If you see just one arrow, it means it goes only in one direction, one-way traffic, not two-way traffic. All right? Some reactions are breakdown reactions. They call them decomposition reactions. Decomposing something. You can break glucose up into their component particles. So if you see, you can make, they have given AB gives A and B. That's very simple. Okay, so it could be like you can take glucose and break it down into carbon dioxide and water, for example, or anything. Water can be split into hydrogen and oxygen. So anything you break up is decomposition. If you do it the other way around, it is synthesis. Okay, so you have decomposition reactions, synthesis reactions, and in some cases you have exchange, like exchanging place. So you can look up the three examples on figure 213. So you have a starch broken down into the component glucose units. This is decomposition. If you build the starch, or if your body breaks down the starch you eat into glucose units, and then it stores in the liver as what? Anybody? The excess glucose is stored in the liver as in what form? As in glycogen. Okay. So breaking the starch you ate was decomposition reaction, but the building up of the glycogen by the liver is from glucose that you already broke down. That's a synthesis reaction. Okay, so same reaction can, if it occurs the reverse, depending on what is being done. Is it breaking up into newer things or making some newer things more complex? Okay, so if you see the synthesis reaction, we have the example for proteins. What are those colored beads? Those are the individual amino acids. So like you put beads on a chain, here we are putting those beads of the amino acids together and making what? Proteins, protein molecules, right? Then exchange reaction, you can have two compounds, one is A and B, two different elements, right? Compounds. So you have C and D on the other side. When they collide or bump into each other, or meaning react with each other, they trade places, right? Can you see that?
Yeah.
So this is an exchange type reaction. And most of these reactions, they can be either one-way or reversible reactions, and they are in a state of what we call equilibrium, meaning they are more or less the concentrations are equal or within a range on either side. So if this side becomes more, when your body pushes this way, the reaction to proceed this way, or if this side is more. So that's how many of the homeostatic mechanisms work, where your internal body conditions are maintained around the set point, which we discussed earlier, positive, negative feedback. So everything you learn is not for nothing, it all relates whenever. So you have to be able to go back and relate some information as you read more and more. That's where we need to go. When you learn, try to relate what you have learned before. Reaction rates. How do we react? Okay. So think of any example that you can deal with in daily life. Okay. You're going to a game. The crowd, whether it's raining or hot and sweaty, all these affect the mood of the players, the game, everything. So if you here you're taking your body, looking at the biochemical reactions, so all these factors affect the reactions too. Concentration. I just told you which side you have more of one versus the other. Okay. Then the temperature. The reactions are affected by heat or cold, meaning temperature. If you guys, I don't know if you did any experiments earlier in any of the labs, school or college level, some of the reactions, they have to be heated for the reaction to occur, otherwise nothing happens. Okay. You have to warm up. And catalysts, what are catalysts? Catalysts are substances that speed up or help to speed up the reaction in whichever direction it is supposed to go. So catalysts. These are substances temporarily bind to reactants, hold them in a favorable position to react with each other, like somebody mediating a business transaction. Think of anything, okay, that can make sense rather than just, okay, learning, okay, this is it. Then we will continue with metabolism. What do you mean by metabolism? We are talking about various reactions happening inside the body. The sum total of the reactions, we call it metabolism. Some processes are constructive, some are destructive, as we saw, the decomposition and synthesis. So based on which way the reaction is going to work, whether you're building something or breaking down something, they call it either catabolism or anabolism. So when you want to remember catabolism, that's a breakdown reaction, like a decomposition reaction. Yeah, go ahead.
Can you give an example of catalysts or typical catalysts?
Usually enzymes are catalysts. If you have enzymes, that reaction will go faster. Some of the compounds you deal with, or some of the molecules like hemoglobin, you have iron in the hemoglobin, and without iron it may not be able to perform the normal function. So you need something besides the substance itself. Okay.
Like if you,
They may have simpler examples in your book. Huh?
like if you somehow people are lactose intolerant, like if you don't have that enzyme that breaks
Yeah.
down milk.
Yeah, so you cannot use the milk protein if you don't have the enzyme lactase. So the lactase will help to modify the protein. Anabolism, catabolism, how do you remember which one is decomposition, which one is synthetic? Think of catastrophic catabolism. Anabolic steroids, okay, anabolism. You have to think of ways to remember besides understanding, okay. Oxidation, reduction, this is a little confusing even after learning for thousands of years. This is one thing always, it confuses me too. So we all get confused sometimes because of the wording, okay. Oxidation is oxidizing something, reduction is reducing something. But what happens? If you look under oxidation, okay, it's any chemical reaction in which a molecule gives up electrons and releases energy. A molecule is oxidized by this process. So anything, we already saw atoms giving up and gaining electrons with sodium chloride, for example, right? So if any atom is giving up an electron, that's considered to be in an oxidized state. And the guy who picked up the electrons is supposed to be in the reduced state. Okay, so the one that oxidizes is the opposite one. That's the oxidizing agent, which is removing the electron, and the other way around is the reducing agent. Okay, so oxidation involves loss of electrons, reduction involves gain of electrons.
Oh.
Whoever is doing is the other guy.
Hmm.
Okay, so that takes, they have given some example, 2 examples, and there's one on the bottom that explains how this happens with A plus B. So the A and B, they go through this process. One gets reduced, one gets oxidized. The one that lost the electron is getting oxidized, and the one that gained the electron is getting reduced. So just basically know the meaning of it, okay? And if you understand what is oxidation reduction, the oxidizing agent is the one that makes it happen. So you have to understand one to understand the other. So it will take some time, okay? So you have to read a couple of times this part. So when you have all the reactions happening, either synthetic or breakdown, meaning decomposition or synthesis, or anabolic or catabolic, we build macromolecules. Okay, most of the macromolecules are built by using anabolic or catabolic reactions. Anabolic, you don't have to look, just have to open your mind and think. Anabolic, I already repeated so many times, is building up something, it's more constructive. Okay, so organic compounds, the major compounds are your proteins, carbohydrates, lipids, and nucleic acids, besides others. But the 4 major categories, all these organic compounds have a general carbon backbone. Depending on the substance, you can write like this or like this. Depending, you can see some examples you will see in the following pages as we move along, or if you have already looked up, and to which you may be attaching other elements. Okay, so I just put something there that doesn't mean anything, but to give you an idea. So you see under carbon compounds and functional groups, you see the carbon backbone that depends on the compound. You may have one carbon to several carbons. Usually organic compounds are made up of carbon and hydrogen, besides other elements. We will see what they are. So when you have the other elements attached, as you see in figure 214, do you see the other colors and the other elements attached? We call them functional groups. So any compound which is considered organic, depending on what is the functional group are these other elements that you attach to an existing carbon backbone that will give them unique properties. So these groups are either hydroxyl, methyl, carboxyl, amino, or phosphate groups. What these groups mean, you need to get used to that. Okay, hydroxyl has a O and a H, oxygen and hydrogen. Methyl has always carbon and 3 hydrogen, that's a methyl group. Carboxyl has 2 oxygen and hydrogen with the central carbon. Then amino, you have nitrogen and hydrogen. Phosphate, you have 4 oxygens and a phosphate in the middle. So these are by nature, okay? These are like rules. Okay? These, when they are added to a certain compound, then they will influence the behavior and property of this compound. That's why they call them functional groups. Okay? First of all, you need to understand what are functional groups. It's given right after the word. And then what are some of the functional groups. So if you are given OH, you need to be able to tell whether it's carboxyl, hydroxyl, or methyl. CH3, whether it's methyl or carboxyl. Okay. Then the easy ones, monomers, polymers. What are monomers, polymers? Mono means what? One. Poly means several. So if you have one single unit of something, it's called monomer. If you have multiple units, they call that polymer. Okay. We need that because later on you will hear like polysaccharides. That means there are many sugar units. Okay. And you will see the use of these poly and mono as we go along. Then you see dehydration synthesis and hydrolysis in the following page, and you have an example on 215. If you have a monomer 1 and a monomer 2, this and this react with the removal of water, and you get M&M. Okay. Most of the synthetic reactions, as you can see in that figure, if you're on the right page, involve dehydration synthesis. But the other way around, so the dehydration is usually involved in synthetic processes. What else can we call a synthetic process? Anabolic. But if it is a catabolic or decomposition type reaction, it's going to be the opposite. Okay, so you have this, you add water, like we talked about sodium chloride disappearing in solution, right? Water. That's a decomposition reaction. It's a catabolic reaction, and what is involved? Water breaks the bonds. So this reaction, the catabolic decomposition type reaction, instead of removing water, you're adding water, and it breaks the bond. So they call it hydrolysis. Okay, so you need to know the difference between the role for dehydration and hydrolysis in reactions. Then they have discussed the individual components, the organic compounds, what are carbs, what are proteins, amino acids, and so on. First of all, we have carbohydrates. We generally call them sugars, okay, but that's not it. But generally, they represent the carbohydrate as CH2O, that's the generic representation. But depending on the carbohydrate we are talking about, the most common being glucose, which has 6 times this. It has C6H12O6. That's the formula for glucose. But then you have more units of glucose, say for example in starch or glycogen. Then you have sucrose, fructose. Some of them are just one glucose unit, or just fructose, like you find in fruit. Some sugars they call galactose. These are all just single units. So we call this these are monomers. We are going to call them monosaccharides. You can see that in that paragraph, monosaccharide. What about sucrose? How many units are there? Anybody? 2. Somebody said 2. Okay. Travis? 2. Okay. Sucrose, lactose, maltose, for example, grains, milk, sugar, the sugar, table sugar. Okay. All of them have one glucose to start with. This has glucose and fructose. This has glucose and lactose. This is made up of glucose and glucose. So when we have 2 units making up that sugar, what are we going to call them? Di means 2, so disaccharides. Okay, and if you have many, you call them polysaccharides. Okay, so you have, sometimes they use mono, di, tri, tetra, penta, going from 1 through 5 and beyond. But commonly they use monosaccharides, disaccharides, and polysaccharides. Sometimes you will see the oligosaccharides. So like 10 to 20 they may call oligosaccharides, even more than that polysaccharides. Then they have given examples of the polysaccharides. What are the 3? Glycogen, starch, and cellulose. Glycogen, where do we find? I said that. Liver. Well, what about starch? In the food we eat. Cellulose, in the food we eat. Okay, in plants, cellulose is found in plants. Glycogen, only animals and humans. Then if you combine some of the sugars with proteins or lipids, they become glycoproteins or glycolipids. You can see those words on the opposite page. They have given the structure for some of the sugars. Thankfully, this is not a chemistry class, and I'm not going to make you learn these structures, but these are very, 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 very important. I don't know when and how you are going to learn, if you haven't done that until now. Okay. Proteoglycans, that's again a combination of proteins and sugars. There are different kinds depending on what kind of sugar is found. So when you have two different things like the sugar and the protein, they use this term MOITY. I hope I didn't switch it around. MOIETY. MOIET. Okay. So if you have a protein and the sugar, the protein moiety is the protein part, the sugar part is the sugar moiety. So you can see that word on the bottom of that page. Okay, moving on. You can see the structure of the glycogen with multiple glucose units linked together by various bonds. Then you can see the function for the carbohydrates. What do they do? Glucose, galactose, fructose, where do you get it from? What is the role? Okay, at least you should have some general understanding of these different sugars. I did talk about some of them as I went through that, like which is in sugar milk, which is in table sugar, which is in fruits, and which one is made up of what are the polysaccharides, where you can find. Okay. I'll give you a minute if you want to look up the table, and then we will discuss about the lipids. Okay, I'll give you about 2-3 minutes. If you still don't have a book, please find one ASAP, otherwise, as you know, it's going to be hard unless you can pick up things just like that. I still see some of you without the book. Like the videos I sent, if you have any problem with any topic, I'm going to be sending as and when we go over some topics, but don't have to wait for that. Okay, I'm doing that as an extra thing from my side to help you. But you have to get used to that habit of exploring, being proactive. Like when you read something, that chapter, okay, I don't have the videos, but you can, all you have to do is to type that and at least look up a few videos. I know some of you do that. I'm encouraging all to do that until I can send. I used to send all the links for my whole lecture, all the topics for the term. And what happens? We all know. We just ignore it in general. Some of us save it and go every week for the class and look up. Some of us, we just forget even where it was. So it doesn't work. So I'm going to try and send us and when we discuss those topics, especially where you need some help with. But if you're waiting on that, it's not good. I will try to send as and when I can find some time in between, because that is not part of my protocol. There's something extra I'm doing. give you an idea of what to look for when you search in YouTube and what videos seem to be like good enough for understanding. Because you see some videos, even I may have a couple of links in that, or I took them out, where the guy stands in front, he blocks whatever he is writing on the board. He is jumping all over the place like a monkey. Okay, we don't want those kind of videos. We want to see what they're trying to tell you. We want to be able to focus. Somebody who stands away and explain, or you have the guy in the inset, so you don't have to focus on him, rather you can listen and focus on what is being explained. Okay, moving on, lipids. What are lipids? Oils, fats. I should have given you the chance. Next time, fats. Okay, a lipid is hydrophobic organic compound. So it doesn't like water. Hydrophobicity, hydrophilicity. Some are hydrophobic, some are hydrophilic. Water can dissolve sugars, proteins, not oil. So your sugars, carbohydrates, proteins are soluble in water, they are hydrophilic, whereas the lipids are hydrophobic. Right there is a difference. Then what are the units that make lipids, the individual units, like amino acids make protein? Fatty acids. Okay, so fatty acids are the individual components of lipids or fats. And some are saturated fatty acids, some are unsaturated fatty acids. Okay, so how do they say that? The carbon had how many electrons? What's the atomic number?
6.
So how many electrons? 6. How do you arrange them? First shell.
2.
2, and outer shell 4. Okay. So you can attach a hydrogen here and make a bond, attach a hydrogen here, and hydrogen here. So you have 4 available spaces to dock. If you are a shuttle and this is the ISS, the space station, you have 4 rooms to dock. Okay. So if all those ports are full, all the docks are loaded, then it's saturated. Otherwise, it's unsaturated. Okay. So that's indicated if you see the examples they have given on figure 219. You remember if the electrons are being shared one pair, a single line, single bond, 1 second, 2 pairs, two lines. So you will see that if you see the carbon in some of them, you will see all single lines. Okay, that means all around you see the single lines around the carbons. That means those are all saturated. But if you see in some cases like the linoleic acid, you see the double bond here and there, right? That's unsaturated because you don't have the hydrogen docking on four sides, only on 3 sides. So you have the double bonds, and sometimes you see more than one double bond. Then they call it polyunsaturated, meaning there are several unsaturated carbons.
So if carbon's sharing all of its electrons, it's saturated.
Exactly.
All right.
Otherwise,
its electrons on its outer level. Sorry.
Right. It is that's the only place where reactions occur, the valence shell with the valence electrons. Exactly. Good question. Okay. So you see the difference between saturated and unsaturated fatty acids, polyunsaturated fatty acids. Some of them that we really need, they call them essential fatty acids. Then you have triglyceride. How does the triglyceride look? The name itself tells you there is something three fatty acids and 1 glycerol. If you want to see that, you can, it's right there in the same figure. Okay, you see the glycerol molecule in blue and the 3 fatty acids. Together they make the triglyceride. Okay, then what do we have in the cell membrane? Phospholipids. So what is the difference? The name itself tells you for most of the things. You have a phosphate unit in addition to the basic structure of the fatty acid. So you can see if you took the lab or if somebody talk to you about in the lab. You may have seen in the class when they talk about the cell. You see the membrane with 2 layers of phospholipids. You can see the structure on page 65, figure 221. You see a portion that's supposed to be the head of that phospholipid, and the rest, the long portion, is the tail portion of the phospholipid. So by the chemical composition, the head portion is more hydrophilic, the tail portion is hydrophobic. So if you take a cell membrane, okay, you'll find these phospholipids lined up like this in 2 layers. So it will complete the entire cell membrane like this. Okay. So normally, because of this tail and this tail, they're both hydrophobic or hydrophilic. Hydrophobic, so they tend to face each other. They stay away from the water on the inside and outside of the cell. So the hydrophobic ends face each other, the hydrophilic heads are on the outside or facing the inside. You have the cytoplasm and you have the extracellular fluid on the outside. Okay. So normally the water-based molecules cannot pass through the membranes. You need those proteins which act like gated channels, or you need vesicles. Vesicles are also made of the same membranes. So if a vesicle comes here with the bilayered phospholipid membrane with something inside, it will come and merge with this, and there will be some rearrangement and the content will be released inside, or it can go outside. I'm trying to explain some basis why the heck we need to know phospholipids. Okay, you will have that question all the time in this course. Some of the examples, they have eicosanoids, one group of lipids we have in the body. Some of the examples under that category are prostaglandins, which we may talk about in the later chapters. They play a variety of roles. As you can see, a bunch of things: inflammation, blood clotting, hormone action, labor contraction, control of blood vessel diameter. So what do we need to know? What are the different categories? The first one is eicosanoids, and prostaglandins are good examples in the category. And the second one is steroids. Cholesterol is the basic molecule from which the steroids are made.
For lipids, since we would use lipids as lubrication for our joints, what would be considered a better, well, because we use, what would be a better lubrication? Unsaturated or saturated?
I cannot answer that. Write down all these questions for me sometime in email, okay? Because there are questions I don't want to give wrong answers.
Yeah.
Okay.
No, I
Some of
understand.
these questions it comes up on a daily basis. Like even I have those questions, but whatever I can answer, I can tell you right away.
All right.
Okay. Thanks for asking. Proteins. We already looked at proteins, what they are made of. Amino acids. How many amino acids do we have? 20 amino acids. That's all there. Like you have 20 colored beads, you can put them together in all combinations possible, and you can make all the chains you want. The same way, the 20 amino acids, you can put them together and make several proteins that we need. Okay. So which are the 20 amino acids? You have them in table 2.8. Alanine, arginine, asparagine, aspartic acid, and so on. And they are abbreviated by the 3-letter codes: ALA for alanine, ARG for arginine, and so on. So what do we need to know? How many amino acids we have? If you are given a name, if you see a name, okay, glycogen, don't tell me it's an amino acid. If you see a name, valine, isoleucine, don't tell me it's a sugar. At least that much you know. Okay, you have to be able to identify at least which is a sugar, which is an amino acid. So there's not a whole lot. This is like you need to know A to Z in order to speak English, right? Yes? The same way you need to know these 20 amino acids if you are continuing in science, in biology. But again, How and when, I don't know. It's up to you. So you don't have to memorize the table, but you have to get familiar with amino acids, how they call them, how they abbreviate them, and how many are out there. Okay? And then you see the structures for some of them. You see in the box in figure 224, you have non-polar and polar amino acids. What does that mean? Can you look at the two figures on the left and right, the methionine, tyrosine, cysteine, arginine? What is that you see where it says polar versus non-polar? Take a minute. I'll give you a minute.